Hello everyone, I am Prithviraj from IIT Madras and I will be presenting our work on the topic Intelligent Graph Planning using Open Vocabulary Image Segmentation and Large Language Models. The main motivation for our work is the rise in popularity of collaborative robots like VR5 and Kuka Eva. These robots have safety guardrails in place that makes them safe to use with other humans nearby. So one possible application might be an assembly task working alongside a human worker. In these cases, it is important for the robot to understand what the human needs and assist them accordingly. Our work aims to bridge this gap by enabling it to process natural human commands from the user and assist them accordingly. Here's a bird's eye view of a proposed framework. We get RGBD images from the depth camera. The open vocabulary segmentation model identifies the objects in the workspace and segments them. Then the LLM specifies the objects to be picked after processing the user input. The point cloud of the object to be picked is generated and its pose is determined. The grasp pose is then generated from the predefined grasp stored, and then the grasp is executed. So the first step in the pipeline is image processing. The color image is processed by DETIC, an open vocabulary segmentation and classification model. DETIC outputs a segmentation mask for the object to be picked, which is then converted into a point cloud using the depth image. It's to be noted that which object DETIC segments out is decided by the LLM based on the query from the user. Now that we have the segmented point cloud, ransack algorithm is run on it using the primitive shape given by the LLM. In the case of a cuboid, the three visible faces of the cuboid are segmented. The pose of the object is then determined. After the pose of the object is determined, predefined grasp poses in the local coordinate frame, which are saved in the system, are converted to the frame of the object to be picked, and then it's sent as a goal to the motion planner. The motion planner then executes the grasp. Here's a small demo of the pipeline in action. You can see that the box has been selected in blue in the workspace. This has also been identified as a cuboid. Now we try to pick up the ball. And we can see that the grasp is successful. So for validation, the pipeline was tested on these two environments with everyday objects. So one of the environments had the objects spread apart and the other had the objects close together in a cluttered sense. During testing, it was found that the pipeline worked well for the thin notebook, the cube, and the ball. A grasp pose was generated for the steel bottle, but then the motion planner could not find a path for it. In the case of the transparent water bottle, the depth camera could not generate an accurate point cloud because it was transparent. Nevertheless, with whatever limited points were available, the pipeline was still able to generate a grasp. The proposed approach was able to adjust for the height of the object. As we can see, there are two kinds of boxes in each environment with different heights. The pipeline was still able to adjust for the height of the object and grasp it accordingly. However, since the approach did not have any collision avoidance built in, there were collisions when the manipulator tried to pick up objects in the cluttered environment. We then compared our approach to the learning-based approach using objects from the IGAD dataset. It was observed that the objects similar to the primitive shapes resulted in successful graphs. You can see the successful graphs on the right. So in conclusion, in this work we demonstrated a novel graph planning and manipulation pipeline integrating an LLM and an open vocabulary image segmentation model. So we use the semantic knowledge of the LLM to determine what primitive shape the object is. The object is then segmented and the primitive-based graph planner executes the graph. This pipeline has significant applications in human-robot collaboration and tasks like industrial assembly and home applications. Future work in this could include expanding to multi-step tasks and more complex object geometries. Thank you.